Okay then, so welcome. Okay, we have Gabrielle from Jamaica, I believe. Oh, here we go. We've got another one just joined. Let's wait for their microphone and everything to connect before I begin. Welcome, Aisha. Okay, you've not missed anything. We're literally just about to start as you connected then, so well done. Good. So welcome to the Key Stage 4 Summer School. And the idea is everything we're going to do today is stuff that will appear on the GCSE paper. Okay, so each week we're going to look at a key topic. The reason I've picked the 4 topics that we're going to look at is one, is every single GCSE paper I've seen, that topic has been on it. Okay, so it's quite likely to come up. Secondly, there's some transferable skills there. And what I mean by that is that what we're going to do today, okay, some of the techniques we're going to do, we'll see appear in other topics as well. So for example, the topic we're going to look at, there's a lot of algebra in it. So it's going to be good that even though this will work well for the topic today, you can use those algebraic skills in other topics as well. And also the topics we're going to look at has a lot of workings out in them. Okay, and in the GCSE paper, it's so important to show your workings out. So I've deliberately picked topics that will force you to do lots of workings so you can get in that habit. Now, throughout any of these lessons, you have any questions at any point, either unmute yourself and just ask the question or type it in the chat. Okay, how you feel most comfortable. If you're feeling confident, it would be great to have your cameras on so we can see you all. But I know not everyone else likes to do that, but it would be great to see you. Sam's got the camera on, which is fantastic. Gabriella and Aisha, if you wish to join, do so. But yes, before we begin, I just want a quick warm up. I know your names, okay, because your names are all in your chat, okay? But I want to know, what country are you in and what year are you born in, please? So can you just tell me in the chat? Okay, make sure we can all use the chat function. Please tell me, what country are you currently in and what year were you born? Type it in the chat, please, all 3 of you. Excellent. So we have someone from the UK and born in 2008. We have someone from Jamaica who was born in 2006. And then we have someone in the UK again, and they were born in 2009. So what we have here is 2 sets of data. One side, I have data about countries you're from, and one side, I have data about the year you were born. So let's get all our brains warmed up. Can someone tell me, what is the mode of the countries you are from? What is the mode of the countries you are on? Now, mode is an average. Yes, Aisha has sent in the correct answer. Well done, nice and quick there. The mode is the most common piece of data we can see. So out of these 3, the most common piece of data is UK. So the UK is an average, is the average answer given, is the modal answer given. Well done, Aisha. Now, for the years, to get the brains warmed up, can someone tell me the range of these pieces of data? The range of these pieces of data. What is the range of these? Oh, go on, Sam.
2, like 3. Is it a difference or?
Yeah, like... yeah. Carry on. It's a difference. So talk me through it. What did you do?
So the largest and the smallest. 2009 was the largest. 2006 was the smallest. So I worked out the difference between them, and it was 3.
Yeah, fantastic. Okay, the biggest piece of data minus the smallest bit of data. Fantastic, Sam. Well done. So yeah, the mode was the UK, the range was the 3. We're not doing statistics today, but I just thought it'd be a nice way to warm all your brains up by using the information we find out about each other. So welcome everyone from the UK and Jamaica. That's quite a fast spread, and the age ranges are pretty close. So what are we going to look at today? We are going to be looking at the nth term. Has anyone heard of this before? Please just either unmute yourself and say yes or no, or say in the chat yes or no. Has anyone heard of the nth term before? Aisha hasn't. Gabriella hasn't. And Sam has. Excellent. Sam, can you tell us sort of what you know about it? How much you know? How far you've got?
I know it's to do with algebra because I remember learning about it in year 7. So it's quite a while ago, but I do remember learning about it. But that's as much as I kind of remember.
Okay, brilliant. Yep, it's definitely something to do with algebra. There's lots going to be algebraic terms we use here. Okay, so definitely something to do with algebra. And this is a very, very common topic to come up in your GCSEs. Okay, so these questions are usually worth 3 marks minimum. It can go right up to like 6 or 7. And what it is all to do with sequences. Now, this is going to be not sort of the only page with loads of information on, I promise. Now, there are 2 types of sequences in mathematics. We have an arithmetic sequence or a geometric sequence. And really the only difference is, okay, is an arithmetic sequence goes up the same amount each time or down the same amount each time. So for example, 2, 7, 12, 17, that's on the screen right now. We add 5 each time. It goes up in 5s. And or the next one, 6, 5, 4, 3, 2, 1, okay, it goes down by 1 each time. They're both sequences and they're both arithmetic sequences because they go up or down the same amount. The geometric sequence is when we multiply or divide to go forward. What we are looking at today is we are looking at arithmetic sequences and how we can generate the nth term of an arithmetic sequence. So all of our sequences today will either go up or down by the same amount every time. Okay, geometric we won't be looking at today. So we are looking at arithmetic sequences. It's those key words that you want to be sort of remembering, okay, as we go along. So let's look at some arithmetic sequences. If my button will work. There we go. Okay, so this is an arithmetic sequence. Okay, it goes 9, 13, 17, 21, 25, 29. Okay, and the term-to-term rule is add 4. Now, what does term-to-term rule mean? Can anyone have a guess? I've told you what the term-to-term rule is, but what does term-to-term rule mean? Feel free to unmute yourself or type it, or if you haven't got a clue, please just say, I don't know, so then I'm not just sat here waiting for someone to type.
I'm not too sure, but
That's okay. Sam's not sure. Aisha's not sure. Gabriella, do you know? Okay, that's fine. Now, the key word here that we need to remember is term. Okay, term simply means a number in the sequence. Okay, and then we can get more specific. 9 is the first term. 13 is the second term. Term means number in the sequence. Okay, so 9 is our first term. So it's the first number in the sequence. 21 is the 4th term because it's the 4th number in our sequence. So term-to-term rule, it means to get from one number in the sequence to the next number in the sequence, we add 4. Okay, to get from 9 to 13, we add 4. To get from 13 to 17, we add 4. So term, again, these are key words. Hope you're making notes of them. Term is number in the sequence. And the term-to-term rule, okay, means how do we get from one number to the next? We add 4. So term, I'm going to say it again, term means number in the sequence. Okay, and same here. Number 15. What term is number 15? Can you all tell me in the chat? What term is 15? Is it the first term? Is it the 10th term? What term? Aisha thinks it's the second term. Sam, Gabriella, what term do you think?
term.
Yep, second. We're all saying second. Yep, it's the second number in our sequence. It's the second term. Well done. And notice here, the term now is -5. So the last sequence was going up. This sequence is going down, okay, because we're taking away 5 each time. And we even end up going into the negatives, which is perfectly fine. We can go into negatives, we can go into decimals, we can even go into fractions when we're doing it sequences. Okay, good. The second term was 15. Brilliant. And one last one we're going to look at. Oops. Oh, Oh, do I only have 2? I thought I had 3. Okay, so now what I want you guys to do, okay, is write out your own arithmetic sequence, but you have to follow these rules, okay? I'm not going to give you 5 minutes. I'm going to give you a little bit less, actually. Is what I want you to do is write out a sequence that starts with 3 and we add 4 each time, which means we'd start with 3, add 4 would take us to 7, add 4 would take us to 11, and so on and so on. Okay, I just want you to do this, get in this practice of writing out these sequences, because these sequences we're going to start generating a rule for soon. Does that make sense? Give me a thumbs up if this task makes sense. Sam's happy. Aisha's happy. Gabriella's giving me a thumbs up as well. Excellent. So I'm not going to give you 5 minutes. I'm going to shorten this down to 3 minutes. 3 minutes. Try and write out all of these sequences, the first 10 terms of each sequence. Okay, I'm not expecting you to do them all. I just want you to get in the routine of writing these out. You can either write them on a piece of paper or you can pop them in the chat, however you feel most comfortable. I'm going to go quiet. Over to you. Okay, then 3 minutes up. Sam, can you continue question 1 for me? 3, 7, 11, carry on.
Yeah, 3, 7, 11, 15, 19, 23, 27. And 31, 35.
Yeah.
39, is that 10?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Well done, Sam. Excellent. Aisha or Gabrielle, which one of you feel confident enough to talk me through question 2, please? Go on in, Aisha. Are you going to do it via the chat? Okie doke. Okay, we've got 7, 17, 27. Keep going. Yeah, 37. Well done. 47, 57, 67, 77, 87, 97, and 107. Well done. The first 10 terms. Brilliant. Gabrielle, can you do number 3 for me? You can either unmute yourself or type it. Okay, Sam spoke it. Aisha typed it. Which one do you want to do? Oh, Gabrielle, which one are you doing? You do -5, 0. You've lost me. Which question did you do? So do you want to do this one? Start with 99 and then subtract 8 each time. So if we start with 99, let me get a different color. So we start with 99, then take away 8. What do we get? Yeah, 99. Next. Good. 91. Oh, Gabrielle, I think were you doing number 4? I do apologize. Were you doing number 4? I think that's where I must have got a bit confused. But yeah, carry on. 99, 91. Keep going. Well done. Yep, 83. Well done. Keep going. Just give us one more. 83 minus 8 would be, there we go, 75. Excellent. Okay, and then we could keep it going. We'd end up with 67, 60, 59, and it would carry on going down like that. Now, Gabrielle, I do apologize because I've looked at what answers you gave me, and I think you must have been working on 4, because if we had -10, then the next one would have been -5. It would then have been 0. It would then have been 5. It would have been 10 and 15. So sorry, I think I may have thrown you off there, Gabrielle, because it caught me off guard because I couldn't see a -5, but then I realized it might have been this one. So well done. All of you got the ones you did correct. Here are the answers. Okay, just if you want to double check what you were doing. Okay, there's the answers if you want to mark what you've done. But well done. Okay, the idea of that was just to get the basics idea of the sequences they generate. Okay, they all went up by the same amount or down by the same amount. Okay, and you've all done your answers very well indeed. Okay, so I'm not going to do this. I think I'm going to skip. I think we're going to jump straight onto this. Okay, now you've all just generated your sequences. Okay, you've found the terms. Now the problem is we could have easily found the 5th term, the 6th term, the 7th term, the 8th term, and we could have keep adding on. However, in sequences, they go on forever. Okay, every single sequence is infinite. Okay, an arithmetic sequence is always infinite because we can continuously add on and add on and add on, and would never get to the end. Okay, the same for taking away. We can take away and take away and take away, go all the way down to -infinity, and if we're adding every time, we can go all the way up to +infinity. So there's always an infinite amount of terms as well, which means we could look for the 50th term, the 100th term, the millionth term, and sometimes these terms do need to be found. If anyone's interested in space, okay, God, there's some big sequences in space which we need to know, some of the really large terms, especially if you're tracking the age of the universe and the patterns that we're seeing in the universe as well. Okay, so we need a way of figuring out how can we find terms in the sequence that appear really far down, which doesn't require us to just keep adding. So for example, here, if I wanted to know what the 200th term is, what I don't want to do is just keep adding 3. I don't want to go 19, 22, 25 and do that 200 times. Okay, because it would take forever. And that's why we need to find something called the nth term. Okay, that's what the title of this lesson was, the nth term. Now, term, we know, is number in the sequence. The nth term is any number in the sequence. The nth, we can say, stands for any number in the sequence we can find if we know what the nth term is. And the nth term is just simply an equation that we need to find. Okay, so I've used lots of keywords there: term, equation, find. Okay, that means we need to generate. Okay, needs to create. Okay, an equation. Okay, that means something we can get an answer to. So we need to find the equation to this sequence. Now, I'm going to show you a couple of steps to this, and these steps are the same for every single arithmetic sequence. Sorry. Okay, so these are 3 key points you want to make note of. If we want to find the nth term for any arithmetic sequence, the first thing we want to do is look at what is the difference between each of them. Okay, what is the difference between 4 and 7? Well, we had to add 3. What's the difference between 7 and 10? We added 3. What's the difference between 10 and 13? We add 3. Notice how I checked more than one. Okay, I went between 4 and 7, 7 and 3. What I was checking here is that it remains the same. Okay, that is definitely an arithmetic sequence. So step 1 for finding the nth term is always find the difference first. Okay, so if you're making notes, that's what you need to write down. Step 1, find the difference. This difference then tells us a lot. Okay, it tells us what times tables that this sequence is similar to. What times table do we know that goes up by 3 every time? And it's not a trick question. So we think of our times tables. Which what's that, Sam?
3 times tables.
Exactly, yeah. The 3 times tables go up by 3. So whatever the difference is here, okay, it's telling us what times tables that we need to look at. And in this case, it's telling us we need to look at the 3 times tables. So let's put that 3 times tables above. Okay, so the second step is find out what times tables it is, which is the difference, and put that times tables above. So this is the 3 times tables, and this is the sequence we want to create the nth term for. We know that both the 3 times tables and this sequence goes up by 3 each time. However, they're not the same numbers. But can anyone spot a pattern between the 3 times tables and our sequence? Can anyone see anything similar with the terms? If we look at the first term of this and this, the second term of this and this, can anyone see what's happening? How we can get from our 3 times tables to our sequence? What do we need to do to 3 to get to 4? What do we do to the 6 to get to 7?
+1.
Yeah, excellent, Sam. What about Gabriella and Aisha? Can you spot that as well? What are we doing to get from the 3 times tables to our sequence? Give us a thumbs up if you agree with what Sam just said, or a thumbs down. Yeah, Aisha agrees. Excellent. And Gabrielle gives us a thumbs up. Yeah, we add 1 each time. Excellent. So to get from the 3 times table to the 1, to get to the 3 times table to our sequence, we add 1, which means our sequence is just the 3 times tables plus 1 more. And that's our equation. Our equation is the 3 times tables. Whoops, whoa, go back. Our equation is simply the 3 times table, which I'm going to express as 3n. So it's the 3 times table is 3n. And then I add 1 to it. So for example, we've got 1, 2, 3, 4, 5 here. If I wanted to work out the 6th term, well, the 6th number in the 3 times table is 18. Add 1 more would give me 19. The 7th term, well, the 7th number in the 3 times table is 21. Add 1 gives me 22. So now I can work out any number in this sequence. And I originally wanted to work out what the 200th term is. So what is the 200th number in the 3 times table? What's 3 times 200?
600.
600, excellent. But we want it in our sequence, so it's 600 plus 1 more, which means the 200th number in this sequence is 601. And that's how we find the nth term of any arithmetic sequence. Find the difference, write the times tables, find out how we get to the times tables to our sequence. That will tell us the nth term. And we express the nth term like this. The times tables as 3n, or if it's the 4 times tables, 4n, or if it's the 5 times tables, 5n, plus or minus the number to get to our sequence. 3 steps: find difference, find the tables, find the journey. How do we get from the times tables to the sequence? So let's try a couple more. I'm not expecting you to get it straight away. So if you sat there a little bit confused, don't worry. I'm not expecting you to get it straight away. But let's do step 1. Find the difference. Aisha, what is the difference between each number? What do I need to do to get from 9 to 11, then 11 to 3, then 13 to 15? Plus 2. Excellent. 9 to 11, I plus 2. 11 to 13, I plus 2. So Gabrielle, what times tables also go up in 2s? And that's not a trick question. Okay, so we found the difference is 2. Now, Gabriella, what times tables go up by 2 every time? If you don't know, just say, yeah, perfect, 2. The 2 times tables go up by 2. So 2, 4, 6, 8, 10. Excellent. So we've done step 1, found the difference. Step 2, found the times tables. Now we need to find the journey. Sam, how do we get from our 2 times tables to our sequence? What do we need to do?
Plus 7.
Plus 7. Excellent. We plus 7 each time. So we have the 2 times tables plus 7 more. We can now find any number in this sequence because we have its nth term. Okay, if we want to know what the 50th number is, well, the 50th number in the 2 times table is 100. Add on 7 more, we get 107. Okay, good team effort there. Okay, we all did a step each. Let's try it again. Who did I start with last time? I started with Aisha, didn't I? So this time, Gabriella. Is it Gabriella or Gabrielle? Gabrielle, sorry. Gabrielle, what's step 1 where we got to find the difference? What do we need to do to get from 3 to 8, 8 to 13, 13 to 8? Add 5. Excellent. So Sam, if we're adding 5 each time, we found the difference. We now need to find the times tables. What's the times tables we need to use?
5 times tables.
5 times tables. Excellent. 5, 10, 15, 20, and 25. So we know we're using the 5 times tables. Fantastic. So Gabrielle found the difference. Sam has found the times tables. Aisha, we now need to find the journey. What do we need to do to get from our times tables to our sequence? Be careful there. Okay, we got to figure out what do we need to do to the times tables to get down to our sequence. So add 2 would be, yes, excellent, Aisha. It's minus 2. Always, what do we need to do to the times tables to come to the sequence? So what do we need to do? The top number to get to the bottom number. Aisha, correctly say minus 2. Fantastic. Always minus 2. Always check a couple to make sure you're right. So it's 5n minus 2. So our sequence is simply the 5 times tables take away 2. So if we want to find out the 20th term, the 20th number in the 5 times table is what, everyone? 20 times 5?
Sorry, 100.
100.
Yep. Yeah, 100, yeah.
Yeah, 100. So there's 100, and we take away 2 to give us 98. So 98 is the 20th number in this in this sequence. A lot quicker working out once we know the nth term, okay, just by subbing it into the formula, the equation even, sorry. Okay, well done. Another good team effort there. Let's try another one. Whoops, go back. Who have I started with? Who did it first? I used to do it first and Gabrielle. So Sam, I think it's your turn now. Sam, start off with step 1. Find the difference, please.
The difference is 15.
Yep, 15. We add
15 times tables.
Oh, stop there for me, Sam. Excellent. Okay, we do 15. Excellent. So Aisha, what times tables are we working with here? We found the difference. It's 15. We now need to find the times tables. What times tables is it we're using, Aisha? Yeah, the 15 times tables. 15, 30, 45, 16, 75. Okay, so it's the 15 times tables. Now, Gabrielle, What do we need to do to our times tables to get to our sequence? Yeah, exactly. You can say -0 plus 0. Yeah, nothing. We don't have to do anything, which means this sequence is just the 15 times tables, which we represent as 15n. It's just a 15 times table. Okay, well done there. Another good team effort. Now, let's have a look at ones. These have all been going up. Okay, these have all been positive. Now we're going to look at that they're going down. Now, the maths does not change. So, Aisha, tell me, please, what's the difference this time? So, what's the difference? What are we doing? Yeah, -2. Excellent. So, Sam, if we're minusing 2 each time, what times tables do we have to use?
Oh, sorry, the 2 times tables.
Not quite. It's nearly the 2 times tables. It's the 2 times tables when we're going up, but it's slightly different.
Is it not the -2 times tables?
Exactly. Yeah, that's exactly what it is. It's the -2 times table. Well done. So this time it's -2, -4, -6, -8. And this is when it starts getting a little bit tricky now, because we've got to start working with negatives. So, Gabrielle, how do you get from -2 to 4? What do we have to do to go from -2 up to 4? We don't add -2. I can understand why you say that, because a negative and negative make a positive, but not in that scenario, because the two negatives aren't next to each other. So it's not add -2. We do need to add something. Anyone confident with negative numbers? Can anyone jump in here? What do we add to -2 to get to 4? Okay, so our negatives are a bit weak. That's fine. That's fine. Let's have a look. If we're at -2 and we want to get to 4, a good way to do this if you struggle with your negatives is first of all get to 0. How do we get from -2 to 0? Well, I add 2. Then how do I get to 0 to 4? I add 4. So altogether, I've added 6. Oh, we just lost Aisha. Okay, so we add 6. Okay, if you struggle with negatives, draw yourself a timeline, get to 0, then get to the number you need to get to. Makes your negatives a lot easier to work with. So this is the -2 times tables plus 6. Okay, so even though we were going down, the maths was still exactly the same. Okay, we found the difference, found the times tables, found the journey. That gave us our nth term. Okay, well done. Let's try one more negative one, and then I'm going to get you guys to practice. So here we go. Let's start with you, Gabriella. Now we haven't got 3 of you. We have 3 steps, 3 people. Now we need to do a different. So Gabriella, I'll start with you. How do we get from 3 to -1, then -1 to -5? What's the difference here? So are we adding on each time? Are we taking away each time? What's the difference? Yeah, brilliant. We -4 each time. Well done, Gabriella. Aisha's back. We'll just wait for Aisha to connect, and then we'll begin again. Just say yes or give us a thumbs up so I know you can hear me. Yeah, excellent, brilliant, cool. Okay, so Aisha, all you missed is Gabriella just told us that the difference is -4. So with that in mind, Aisha, what times tables are we using then? So we found the difference is -4. So what times tables do we need to write above? Not 4, because this is going down by 4 each time. So it's almost a 4 times table, but not quite. -4 times table. Excellent. -4, -8, -12, -16, -20. So Sam, over to you. What's the journey now? How do we get from -4 to 3?
-1. Wait, no. Is it?
It's not -1. No, if you're struggling, remember, draw a timeline, a number line, get to 0, then get to 3 from -4.
Oh, right. Yeah, that's 7. So
+7. Yeah, excellent.
-3. Yeah.
No, well done. No, negative numbers are really tricky. So if you, just draw a number line. Sometimes it helps it. go a bit clearer. So well done, Sam. We add 7. Excellent. So a good team effort there again. It's the -4 times table, which we express as -4n, plus 7. Good. We're getting there. We're getting there. Let's give you all some time to practice them. So all of these are positive. Okay. If you feel like challenging yourself, there's some negative ones on the extension side. Okay. What time have we got? I'm going to give you 8 minutes. Okay. Try and find the nth term for these sequences. So remember the 3 steps. 1. In fact, what was the first step? Remind me, what did we have to find first? What's the first step? Find the what?
Is it find the times? Find the difference.
Find the difference. Excellent. Perfect, Sam. So first step is we find the difference. Step 2. What was step 2? We find the what? Times tables. Excellent, Aisha. Yeah. We find the times tables. Well done. And step 3. I should have typed this really. My writing looks terrible. So we found the difference. We then find the times tables we put at the top. What's the final step? What's the final thing we need to find? I was calling it something beginning with J. The journey. So I was calling it the journey. Remember, it's just how we get from the times tables down to our sequence. Okay, do we need to add to get to the sequence? We need to take away. So just do those 3 steps. Find the difference, find the times tables, put them above, then find the journey. Thumbs up if you feel confident that you can go ahead and find the nth term for these. Sounds good? Aisha, Gabrielle, do you reckon you can do it for some of these? Kinda. Okay, I'll take that as a thumbs up. Aisha and Gabrielle, you okay? Think you can do it? Yes, excellent. So what I need to do is answer A, send me the answer for A, and if you've got it right, I'll say, yeah, carry on. If you get it wrong, then we can sort of work through it together. Just direct message me your answers in the chat. You've got 8 minutes. Off you go. Ask for help if you need it. 2 minutes remaining. If you haven't already, please send me your answers or any answers you have. But the ones I have got so far are going very, very well. Well done. $60 seconds left then we're going to go through the answers. 60 seconds left. Okay, I'm getting some fantastic answers come through. You guys have really picked this up really, really well. Well done, you three. Excellent. So what I'm going to do now is put the answers on the screen. Okay, so you're going to see the nth term come up on the screen. What I want you to do is mark all the work you've done and then send me through how many you did and how many you got correct. So for instance, if you mark yours and you got 7 correct and you did 10, send me 7 out of 10. If you did 4 and got 3 right, send me 3 out of 4. Okay, so here are the answers. Okay. Let me know how many you did and how many you got correct, please. But all the ones I've seen so far, yep, Aisha, another correct answer there. Brilliant. Okay, Sam, Aisha, Gabrielle, all sent me perfect answers. There you go, the answer on the screen. But I've been well impressed. Everything that people have been sending through to me has been correct. Let me know how many you did and how many you got correct, please. So yeah, Aisha, did you do any more than that? Gabrielle, that's brilliant. Well done. Sam, did you do any more than that I've seen?
Yeah, I did. I didn't put them in chat. I just put them onto the sticky notes thing I have on my screen. So
yeah, that's fine. So just mark them on the sticky notes and then just send me through how many you got right. You don't need to send me. Yeah, brilliant. So Aisha, well done. Gabrielle, excellent. That is brilliant. Just wait for Sam. I'm sure he's done very well as well. Brilliant. Okay, that is some excellent work from all three of you. So good. Okay, well impressed. Okay, because none of you had really heard of this. Sam knew it was a little bit to do with algebra. Okay, but apart from that, this was a pretty new topic, and you've all just smashed that. That's really, really good. So the final little bit of work I want us to do in the last 2 minutes is these are the nth terms. These are the answers. Can you find me the 14th term in each of these sequences now? Okay, so remember, we times by the times table. So for it to be 14 times 2, add 1. 8 times 14, add 4. 10 times 14, add 9. I'm going to give you 60 seconds, okay, to send me through as many of the 14th terms as you can find. I'm going to go quiet, and I'm going to speak again in 60 seconds. Send me through your answers in the chat through a direct message. Off you go. Okay, 60 seconds up. And once again, all the answers you sent through were correct. Okay, absolutely brilliant work from all three of you. Okay, not an easy topic, especially not an easy topic to cram into 1 hour. Okay, and you've all done so well. Okay, really, really impressed. Keep this up for the next 4 weeks. Okay, we're going to then smash 4 topics and you're going to start your GCSE program flying. Okay, really, really good. Okay, because you've done lots of skills here. Finding the difference in the times tables, of course, that's your basic multiplication, which you've all done really well at. Okay, creating your own equations. Okay, the 2n's, the 8n's plus 4's, all that sort of stuff. Okay, that's not easy to do, and you've done it. And now you're using those equations to find terms as well. Okay, that's 3 key things you've done today. And hopefully you're all showing your workings out on your piece of paper in front of you. I'm sure you are. Okay, so well done. Lots of stuff covered. You've all pretty much got every single question you've done correct along the way. Fantastic. Please give me a thumbs up if you feel confident with the nth term, or give me a thumbs down if you don't feel confident. Aisha's got a thumbs up straight away there. Brilliant. Gabrielle's got a thumbs up. Sam's given us a thumbs up as well. Brilliant. Well done, you three. Cannot praise you enough. Excellent, excellent work today. Have a fantastic rest of the day, and I'll see you this time next week.